In this section, we'll explore key concepts related to electronic data capture systems, focusing on considerations for effectively managing data input and output. When selecting an EDC platform, one of the critical factors to assess is how easily you can import external data into the system. There are various methods for achieving this depending on the specifics of your study. Importing data. An essential capability of any EDC system is the ability to support batch data uploads. This is particularly useful when you have large data sets such as lab results that you do not want to enter manually. Instead, the lab can send you the data in a file format, which you can then upload into the system. The key benefit here is that once the data is uploaded, the system can automatically perform validation checks, just as it would if the data had been manually entered. This ensures consistency, accuracy, and reduces human error. Another scenario where data imports come into play is when you're transitioning from another system. If you've been using a different tool for data collection and decide to switch to a new one, you may want to transfer existing data into the new platform. This can be a bit tricky, especially if the data quality is uncertain. Careful handling is required to ensure that any existing dirty data does not compromise the integrity of your new study's database. A robust import module in the EDC system can help facilitate these processes. The system should allow you to upload data in a predefined template, which can be generated based on your study's data dictionary. The template ensures that the imported data is formatted correctly and aligns with the system's data structure. Once uploaded, the system performs validation checks and provides feedback on any errors, allowing you to make corrections before the data is officially imported. Study scheduling and calendars. When conducting clinical or translational research, especially with human subjects, it's important to manage and track visits, study events, and schedules. If you're managing a study with numerous visits spread over multiple years, keeping track of which tasks need to be completed on specific dates can be cumbersome. Study calendars within an EDC system help automate this process, making it easier to schedule visits, track appointments, and ensure that all necessary procedures are performed. In studies with multiple treatment arms or large patient cohorts, an integrated scheduling system helps streamline coordination between research teams, ensuring that all parties are aligned on what needs to be done and when. By embedding a study calendar within the EDC platform, you can reduce administrative overhead and improve overall study efficiency. Data cleaning and visualization. Data cleaning is a crucial step in the research process, and while EDC systems can automatically validate certain aspects of the data, such as ensuring numbers are entered where expected or dates are in the correct format, there are still instances where errors may slip through. Data visualization tools within the EDC system can aid in this process by providing a quick overview of the dataset and helping to identify outliers. For example, by visualizing continuous data, such as age or weight using graphs like scatter plots or jitter plots, you can easily spot any values that are far outside expected ranges. This visual representation helps the research team quickly flag potential errors, which can then be addressed by reviewing the individual case reports. This eliminates the need to export the data into a separate statistical program for cleaning, saving both time and effort. Being able to create custom reports is another important feature to look for in an EDC system. Often, researchers need to view only a subset of the data for specific analysis purposes, without having to export and process the entire dataset. A flexible reporting module allows users to specify which fields they want to include in a report and apply filters to segment the data based on specific criteria. This ability to generate reports on demand empowers research teams to focus on relevant data, without the need for programming expertise. It's a significant advantage for teams that need to analyze data on a frequent basis without relying on IT support. Multi-center collaboration and data access control. In studies involving multiple research sites, it's essential to have mechanisms in place to ensure that each site has appropriate access to data while maintaining confidentiality. Multi-center functionality in an EDC system allows for site-specific data access, meaning that researchers at one site can only view their own data, while the study coordinator or lead researcher can access data from all participating sites. This level of data access control ensures privacy and security and helps maintain the integrity of the study by preventing unauthorized access to sensitive information. Furthermore, the system can support centralized queries and data oversight, allowing the study coordinator to monitor data quality across sites and resolve issues as they arise.
Support for multiple languages. For studies that involve participants from diverse linguistic backgrounds, particularly in global health research or multi-country studies, the EDC system should be able to accommodate multiple languages. This feature ensures that the platform can render case report forms, surveys, and instructions in the native languages of the study participants. This is especially important for ensuring informed consent and accurate data collection across different cultural contexts. The EDC system should also provide tools to easily translate survey options, drop-down menus, and other form elements to ensure consistency and minimize errors during data entry. For larger-scale studies conducted across different regions, the system should allow researchers to switch between languages seamlessly.
Open architecture and data access. One of the key principles when designing or selecting an EDC system is ensuring that the data is not held hostage by the system. Open architecture in this context refers to the ability to integrate the EDC system with other platforms, tools, or databases. It's important to choose a system that supports API or Application Programming Interface integration, which allows external applications to interact with the EDC system securely. For example, if you need to pull data into a statistical analysis tool or a web-based application, the EDC system should allow you to query the data in a secure and efficient manner. This capability is essential for creating robust cross-platform workflows and for ensuring that the data can be leveraged by other systems as needed without being restricted by the limitations of the EDC platform. Conclusion. When selecting an EDC system for clinical research, it's important to choose a platform that balances ease of use with robust functionality. The system should provide tools for data import, export, validation, cleaning, and reporting, as well as support multi-center collaboration and data privacy. A well-designed EDC platform will also offer flexibility in terms of language support, integration with other systems, and the ability to create customized reports without requiring advanced programming skills. By focusing on user-friendly features and ensuring that the system can accommodate both small and large-scale studies, you can help streamline the data collection process and improve the overall efficiency of your research. Ultimately, an EDC system should empower research teams by providing them with the tools they need to manage and analyze data effectively without overwhelming them with unnecessary complexity.